Let's work through LeetCode 206 reverse linked list. This is an easy linked list question, and it is a frequently asked coding interview question, so it is important that we know how to solve this question. The question reads, given the head of a singly linked list, reverse the list and return the reversed list. If we look at an example 1 here, we'll see that our head is 1, 1 points to 2, 2 points to 3, 3 points to 4, 4 points to 5, and 5 is our tail. But in the reverse linked list, our old tail becomes our new head, our old head becomes our new tail, and every single pointer just flipped. So a solid approach to this, and the most optimal approach to this, is to use 3 different pointers. Why do I say 3 pointers? We're going to have 3 pointers. One is going to be previous, which is going to be trailing. We're going to have a current node, which is going to be the node that we're going to be updating the pointer of. And then we're going to have a next, which is going to help us traverse through the entirety of the linked list. I've gone ahead and wrote some pseudocode, but do not worry. I will take my time to explain everything to you. Previous is equal to null is the initial statement, which you see right here. In most linked list situations, all we have is this. So if we want to create a node or a pointer to a node that is always going to be trailing, we have to go out of our way and create that. That's how this whole section right here comes into fruition. Then we have to create a pointer called current. Cur is just short for current, and we're setting it equal to the head because we are passed in. Let me go back to the code here. We'll see that in our method reverse list, the only parameter we're passed in is a list node head. So we could utilize that head to give the initial value of cur. Now you'll see right here, I created next, but I didn't give it a value. The reason I didn't give it a value is because we had to think about all the cases where we could have an empty linked list, or we could have a linked list with only one node, and there's many edge cases. So we don't even know if this next really exists. So let's not get too ahead of ourselves and give it a value initially. So I've left this while loop condition empty because I want to visually walk through this question and figure that out for ourselves. But you'll see that every time the while loop condition is true, then we will establish our next pointer to be the node that comes after our current pointer. Then what we're essentially doing, since we have this previous value, which is always trailing, and since if you look right here, uh, 2 is trailing 3, but in our new linked list, 3's pointer comes to 2. So essentially what we're doing is every node that we're at, we're updating its pointer to be whatever trails it. So 3 trails 4, so 4's new pointer becomes 3. 4 trails 5, and 5's new pointer becomes 4. So that is the reason that we have a trailing pointer. I called it prev, short for previous. You could call this trail. You could call it whatever you want. But just make sure it's something in your head that makes sense, that it's something that's trailing. So essentially, by doing cur.next is equal to previous, on the first iteration itself, what I'm doing is this one's pointer is to 2. I'm going to delete that because I'm setting a new pointer myself, and I'm setting it equal to previous. And we know previous is right here. So this first line, or second line, I should say, inside of the while loop, gets 1 to equal null, which is good because we know 1 should be the tail, and tail always points to null at the end of a linked list. Now, what do? We do previous is equal to cur. Why do we do that? Is because we need to keep traversing this linked list. You'll notice right now, we lose connection in our linked list right here. 1 has a pointer, but there's no way of connecting 1 to 2 anymore. 2, 3, 4, 5 are still connected, but we've created 2 distinct linked lists right now. But we need to make sure it stays connected. And by moving previous is equal to cur, we are just traversing forward into our linked list. So essentially, I don't need a memo. Could you close? Thank you. We could erase this. And now previous is pointing to whatever our cur is pointing at. And then we're going to say cur is pointing to our next. And we know next is going to be whatever node is after our current. Why does this help us out? It's because right when this while loop comes back around and the while loop statement is met true, we're moving next over again. So next moves from here to node 3 because our cur is now 2. Does that make sense? We're using these nodes to help us traverse the linked list while also bridging the gap that we're creating between the linked lists. So give me a moment while I just go ahead and fix this visually. So our second time around in the while loop, after the first line, which sets next is equal to cur.next, we establish next to be at 3. Now again, we're doing cur.next is equal to previous. So cur.next currently is pointing to 3. We're deleting this connection right here. After we delete this connection, we're saying cur.next is equal to previous. So we're creating a new connection from node 2 to node 1. And you could see how we're already reversing the linked list, but I will go through this entire question to make sure it makes sense for you. Now, again, we're setting previous is equal to our current value, so that moves it to right here. And then we're saying our current value is equal to our next value right here. So this is the end of the second iteration of the while loop. And give me a moment while I fix this visually, and we'll move on to the third iteration of the while loop. So now we're at our third iteration of the while loop, and we know next is equal to cur.next, which we're going to place next at the node that has the number 4. Now cur.next is equal to previous. What does that do? We go to our cur, which is 3. Then we say, let us delete this pointer that goes to 4. And then let's create our pointer that goes to previous. Now that we've done that, we're going to traverse again, and we're going to say previous is equal to our current. And then we also said that our current is equal to next. So let me fix this up, and I'll show you the fourth iteration of the while loop. At our fourth iteration of the while loop, our previous pointer is pointing at node 3, our current pointer is pointing at node 4. The while statement, we go to true, and we establish our next pointer is equal to our cur.next. So next is right here. Then what do? We say cur.next is equal to previous. What does that do? It deletes this pointer between 4 and 5, and then it says, hey, 4 now points to 3. After we do that, what do? We traverse our pointers again. We move previous to what was our current, and then we move our current to what is our next. And I will show you the fifth iteration of the while loop. Now we are at the fifth iteration of the while loop. We will see that we set next is equal to cur.next, which is going to put next pointing at this null right here. Then we say, hey, get rid of this current dot next and set it equal to the previous. So it's saying 5 now points at 4. And we'll see, we're going to actually run this still, which is traversing everything, which is going to say, hey, previous, you're now at cur. Hey, cur, you are now at next. But we'll see that our current is now at null, and you'll see that our previous is actually at the end of the linked list. So what does this tell us? It tells us exactly what we need to fill in the blanks that we have here. We're going to keep iterating while cur does not equal to null, because we see up here, when cur reaches null, we've reached the end of the linked list. And the question had stated before, hey, once you have returned the linked list, return the reverse list. And how do we do that exactly? Well, we just had to return the head of the new reverse list. And if you look at it, at our final iteration, previous is pointing at our new head. So all we have to do is return previous. So I understand that the pseudocode is already written out for us. Maybe you're still wondering, hey, why do I need three pointers in general? The reason you need three pointers in this situation is highly due to the fact you can't solve this question using simply two pointers. At least I don't believe you could, because you're going to keep creating this bridge, and this bridge it's gonna have no connection if that makes sense. You after you do cur.next is equal to previous, you have no connection to what is to the right of that linked list. You always need a pointer next, which allows you to just keep jumping our cur to the next actual node in the linked list. If we don't have that next, we lose this connection as we're reversing the linked list. And we want this linked list, this reverse linked list, to be completely one piece. That's why we need all three of these pointers. So now let me jump back over to LeetCode and let me do the entire code. So we see that in this question specifically, nodes are specified as list nodes. So I will do so, and I will say list node prev is equal to null, which is for our first iteration, because we know we want to point one essentially to null because it is the tail. But if we don't go ahead and do it ourselves, there's nothing that's going to do it for us, because in the original linked list, there's nothing to the left of 1. Then we have to create our list node current, and we know that we're passed in a list node head, which was originally 1, and that's where we want our cur to start from. So we'll just say list node cur is equal to head. Then we know that we need the next, but we don't want to initialize it originally. Now we create our while loop to traverse the linked list, and we said, hey, we're going to keep doing this while cur does not equal null, because when cur does equal null, we have reached the end of the linked list. Every time we open up this new traversal, we're going to establish that our next pointer is actually at current.next, which allows us to essentially just keep track of what originally was um, cur's the current node's pointer, because we're going to be updating current's pointer in the next line right here when we say, hey, current.next is no longer whatever the next node was, it's actually the previous node. Then we want to keep traversing, so we say, hey, move previous up to our current, and let's move our current up to the next. And like we saw in the diagram right here, when we reach the end of the linked list, previous is pointing at 5, which is the head of the new reverse linked list. So we could go ahead, return previous. I could run this code, and we will see that this was a grand success. I hope this helped you guys out. If it did, please feel free to leave a like. Thank you.